denominator? What will you do? Focus on what you think. Divide by what? 7 a squared and bracket a minus 3b bracket squared. Okay, so this will be the common factor that is found in both the numerator and the denominator. Okay, so we're looking at division of this. So in other words, I'm going to be left with 1a on the numerator. For the a minus 3b, I'm left with 2 of them. And then in the denominator, I will have 21 divided by 7, that is 3. A squared is gone. B, I still have it. And then a minus 3b bracket square is gone. So my answer will just have a denominator of 3b. Okay, that will be the answer. That's all. Alright? Then for question 5G, we will need to do a factorization. So how will we factorize the numerator? Alicia, what do you think? How do we factorize the numerator? Is that we need to do a squared minus b squared. So how do we apply this? Plus y, 9x minus y. True? No disagreements? If no disagreement, we accept this as answer. Yes, Kelly? It should be 3x plus y. 3x plus y, 3x minus y. Why is it so? Because 9x squared, the square only belongs to x. It doesn't belong to the 9. So our understanding should be 3x bracket square minus y squared. Okay, which results in 3x plus y, 3x minus y in the numerator upon factorization. Okay, so this is what happens to our numerator. Now what about our denominator? How do we factorize the denominator? How to factorize the denominator? Cross factorize, okay, cross method. Alright, so we get y squared, negative 3x squared here, minus 2xy. Okay, so y and y, 3x and x, cross 3xy, cross xy. To get a negative 2, it must be negative 3 plus 1, negative 3 plus 1. Okay. So we will have y minus 3x and y plus x. Alright? So we should be able to arrive at this juncture if I can do factorization. Okay? But then here's the problem. Over here we see that in our numerator we have 3x plus y and 3x minus y. In the denominator, we have y minus 3x and y plus x. Okay, so at least we must be clear that 3x plus y and y plus x, they are not in common in the numerator and the denominator. But there is something that looks common in the numerator and denominator, which is the 3x minus y and y minus 3x. They look common, but they're not the same, they're not equal. So yesterday I have addressed that if I want to have 3x minus y to eventually become something equal to y minus 3x, okay, we think about it by switching the terms to write it as negative y plus 3x first, but clearly these are not the same, okay, and then we need to factorize out the negative 1 to get negative bracket y minus 3x. So to make them looking similar, okay, to have the y minus 3x, I can have a negative sign outside. So perhaps switch this one around. I'll place a negative 1 on the outside. Okay, and then now I can divide away the y minus 3x. Or in other words, I'm looking at cancelling away. So I will get negative 3x plus y on the numerator, and then in the denominator, y plus x. Okay, we can simplify this further. Several options. Either put the negative sign on the outside of the fraction. On the numerator, it remains as 3x plus y. Denominator, y plus x. Or you can put in the numerator negative 3x minus y, where we open up the brackets, divided by y plus x. Okay, so several ways of writing the same thing. Okay, they are all acceptable. Questions? We'll use your calculator to help you out. What is 24 divided by 64? 3 over 8. So the answer is 3 over 8. Right? Questions? Okay, if you're good, will you please submit your homework to the front, please? Algebraic fractions, where the very critical thing is that in deciding the denominator for our combined fraction, we need to choose the lowest common multiple, okay, of the denominators that we have. So yesterday we were looking at practice now 5, okay, question 1, right? So we look at, for example, part A. When we have these two fractions, what is the denominator that we will choose? 5a and 8a, what denominator will we try to get? 40a, right? Okay. Because the lowest common multiple between 5 and 8 is 40. Okay, so we get 40a. Then I just conveniently combine it into a single fraction directly. If you want to, of course, you can do it into separate fractions, but I don't find that necessary. I just do the combination directly. So I'll have 6 times 8 plus 3 times 5. Okay, I'm not going to solve this because we already did it yesterday. Then in part B, we also saw that we have 2b plus 3c as a denominator for one of the fraction, minus away 6b plus 9c in the other fraction. Okay, so in doing this question itself, the skill that we saw is that we need to have the observation of the denominators to notice that this is a multiple of your 2b plus 3c. So we will do the factorization where we can factorize our 3. Okay, to see that 6b plus 9c is actually a multiple of 2b plus 3c. And in such cases, we will get a common denominator of 3 times 2b plus 3c. Okay, whereby over here my 4 will multiply by 3, and then my 7 multiplies by nothing, which is actually a 1. So this was what we did yesterday, right? Today let's take a look at part C. What if I have h over 2 minus 3k minus 3h over 3k minus 2? Okay. So what observations do we make regarding the denominator? We have 2 minus 3k and 3k minus 2, right? Do they look similar? They look similar, right? But are they equal? They are not equal. How can we make it even more similar? In the sense that, can I switch the 3k minus 2 to become 2 minus 3k? Can I do a switch over here to make it the same? I can, right? Because what we learned just now when I was going through question 5G, right? We learned that if I want to have my 3k minus 2 being switched to become 2 minus 3k, I need to have a negative sign in front of brackets, right? Okay, my minus sign from the question, I continue to write it here. I also continue with the 3h. Okay, so what I've done at this question, at this juncture, is that I solved the way I write my 3k minus 2 into 2 minus 3k, but I need to have the negative sign and my brackets. Right? So we know that my negative sign in the denominator, I can always bring it up into the fraction. So negative and negative can become a positive, right? So I can write this as h h over 2 minus 3k plus 3k over minus 3k. Then now, do we have the same denominator? We do, right? Okay, and what can we say? If I want to combine it into a single fraction, what will my denominator be? 2 minus 3k. So I will have h plus 3h. Okay, so h plus 3h, that will become 4h, and therefore my answer will simply be 4h over 2 minus 3k. Review exercise 6. This is question 3C. Okay, what if I have 9 over 2d minus 4f plus 7 over 8f minus 1? Okay. I let you have a try at this. Give you about 3 minutes. Give this a try. through this together. Alright, so what is the first thing that you did? Okay, let me just call a name, get ready to stand. So, Faith, tell us, what did you try doing first, your first step? Okay, you change the F minus 4D, what do you change it to? 2D minus 4F, okay? So let me write the remaining components. Okay, so this is what Faith has. Do we agree with what she has? Okay, maybe some of you may have taken a slightly longer way to arrive at this. Okay, but I believe that we are able to get this. Okay, so maybe some of you, if you didn't understand why she got this, okay, just to explain, we notice that AF minus 4D is somewhat a multiple of 2D minus 4F. Okay, because first of all, if I were to switch it around, so I'm just writing out the distinct steps for those that can't see this immediately. Okay, so what she has done is that to switch this around, I'll put a negative sign. And after that, 4D minus 8F. Okay, negative can give me a positive, right? So I can have a plus here, and then I have 4D minus 8F, right? 4D minus 8F is actually a multiple of 2D minus 4F, so we can factorize our 2. Okay, so essentially this is what, hang on, sorry, this one is a plus originally, now here is a minus, then down here should be a minus. Sorry, my bad. Okay, so what Faith has not yet done is consider the plus and minus, give us a minus in the end. So in our next step, we will have a minus sign because plus and minus gives us minus 7 over 2D minus 4F. Okay, so I arrive at this step. So depending on yourself, if you don't want to force it, you are just trying to develop a concept first, no harm doing it step by step. Okay, I'm not rushing us, right? Once you get the hang of it, you understand what's going on already, of course you can immediately jump to this step without a problem at all. Okay, it's important that we understand what we're doing rather than doing things blindly, okay, or behaving like a robot, okay, not knowing what you're doing. Okay? Then after that, from here, okay, where did my 2 goes? 2D minus 4F. Okay, so from here, what is our next step? Let's pick another person. Ethan. Actually looks like this one. Okay. So Asher, can you tell me what is our next step? Are we combining the fractions already? What have you tried? Huh? What is the denominator that you get? What denominator? 2D minus 4F. I can't. 2 bracket 2D minus 4F. Okay, so this being a multiple of this, the lowest common multiple will be the larger one, right? Okay, so 2 times 2D minus 4F. So therefore, in my numerator, this 9, what happens to it? I will have it 18 because 9 times 2. What about the 7? Any change? No. So minus 87. Okay. Then after that, you can press into your calculator for 9 times 2 minus 7, which is 18 minus 7, that is 11. And then arrive at this as answer. Okay. Just wondering, would anybody be thinking of expanding the denominator? Okay, there's no need for us to expand the denominator, you can keep it factorized. Okay, so I don't see the need to encourage you to go and expand it now. Okay, I also worry that what if you expand wrongly, then it defeats all your efforts. Okay, so don't need to go and expand it, just keep it this way. Alright? Factorize the denominator further. Oh, okay, I didn't notice that. You're right, okay. Yes, you can factorize it further, but I wouldn't see that need for it. Okay. Yes, you're right, you can factorize it further. Get it like that. So I was focused on the 2D minus 4f, but I didn't notice that it can be factorized as well. Right? Questions? Okay, so several things that we observed from this set of questions. One is to learn how to get the lowest common multiple. The other one is to observe for multiples between one denominator to the other denominator. And then the other skill that we have learned is how do we switch, okay, from 3k minus 2 to 2 minus 3k, okay, by placing a negative sign in a set of brackets, right? And then over here in this question, it was a combination of everything, okay, everything that we did in 1A to 1C. Okay, so let's move on, right? Let's look at another set of questions. Your practice now 5, question 2. Okay, so in part A, before I forget, play and measure points. Okay, we have over here in part A 2m plus 3n over 3m minus m minus n over 6n. Okay. The denominators share different variables. So, what common denominator are we going to get? Okay, between 3 and 6, what is the lowest common multiple? 6, right? Okay, so our denominator wise, we choose 6. Okay, m and n. What's the lowest common multiple if I have m and n? Okay, I hope nobody's thinking of O or P or I don't know what other letters. Okay, so m and n, that one no choice, we need to have both of them. Okay, so the denominator needs to have m and n. Right? So we decide on the denominator already, then we look back at the fraction that we have. We originally have 3m in our first fraction. Now we need a 6mn. What do we need to multiply? I need to multiply by a 2 and n. Right? So I need to multiply by a 2n in order to get 6mn. Okay? So therefore in my numerator, I also need to multiply by a 2n to the entire numerator. Yeah? Okay? So therefore, what I write here will be 2n multiplying by 2m plus 3n. Okay. Then what about my second fraction? What do I need to do to this 6n to get 6mn? What do I need to do? I times n, right? Okay. And then over here, I will also multiply by n. So therefore, a result of the second fraction, I will have minus m times n minus n. Okay? Any questions? Alright? Then after that we proceed to simplify the numerator. What will we do? Or what will you have done? What should we do in the numerator? Expand, okay, in order to simplify. So 2n times 2m, I will get 4mn. Then 2n times 3n, I will get 6n squared. So your rainbow method. Okay. Likewise, in my second one, I have negative m going towards my m and my negative n. So I will have negative m squared plus mn. Denominator remains as 6mn. Okay. Continue to simplify. 4mn and 6 and mn, they are like terms, so I will get 5mn plus 6n squared minus n squared over 6mn. Okay. Right? You may give the answer as such. Okay. Or if you notice, your numerator, okay, can be written as 6n squared plus 5mn minus m squared. So you can leave the answer at here already, not a problem. Okay. But your numerator could actually be further factorized by doing our cross method. That's also fine as well. Okay, so either these are acceptable answers. It is not all the time that your numerator can be further factorized. But if your strength is not there, okay, so here we can just stop it. Since I think it's obvious that there is no common factor between numerator and denominator anymore. Okay. it? Okay. And then in my second fraction, what do I get? Okay, 3 bracket p minus q. Alright. So we factorize the denominator. Thank you. Have a seat. Okay, and we get this. Alright. Now that we have this already, okay, what will the lowest common multiple for the denominator be? What will the denominator be? Let's see. Most impactful one. What will the denominator be? Cancel the p minus q, cancel from where? My question is, what is our denominator? I'm not yet cancelling. Huh? 12, okay. And then anything else? And p minus q, yes. Okay, so between 4 and 3, lowest common multiple is 12. For p minus q, they are common in both, so we just take p minus q. Right? So now we ask ourselves, from this original denominator to arrive at the 12p minus q, what do we need to do? We need to multiply by a 3, right? Okay, so therefore I will have 3 bracket 3p. Right? Then in my second fraction, in order to achieve a 12p minus q in my denominator, I multiply it by a 4 in both the numerator and denominator. So I will have minus away 4 times 5p minus 2q. Okay, then I proceed to expand the numerator. And then simplify. Point to note again, this is a negative 4. So when expanding, take note that negative times positive gives us negative. Negative times negative gives us a positive here. Then there are like terms 9p minus 20p, that will give us negative 11p plus 8q over 12 times p minus q. Okay, you can leave your answer as such already. Take note that the negative sits on top of your fraction. Okay, it doesn't come outside of the fraction. It will mean a totally different thing to do there. Okay. I think we're getting a hang of it. So, what time is it? Okay. I think we have time. Let's go with Chin's request. Make your copy. Let's look at part C. Okay, we have 5x over 4x minus 3y minus 7y over 6y minus 8x. Okay, how do we simplify this into a single fraction? Right, I'll give you 5 minutes. Then I'll invite y representative from each group. Okay. Answer of 10x plus 7y over 2 times 4x minus 3y. Do we agree with the steps that they have taken? Right? In fact, actually, it's all presented in a different manner. Okay. Although they arrive at the same answer, they have taken different steps, right? Okay, algebraically they are all correct. Alright, so let's look at what Kenny has given us here first. Kenny gives us this, right? Kenny wrote that side. Then this one who wrote? Then this one is Xavier. Okay, wait, now, so Kenny here, right? Okay, so let's look at what Kenny has given us, right? So what Kenny has done is that she decided to swap the 6y minus 8x first. Okay, in swapping it, the negative sign comes out, so combines with this negative sign, so we get a plus and 8x minus 6y. Okay, so that is the impact. The first step. Okay, then she noticed that 8x minus 6y is actually 2 times 4x minus 3y. Okay, so she didn't do the additional step in terms of factorization. She noticed it internally already. Okay, then after that, she combined both into a single fraction to get this. Right, so the denominator is your 2 times 4x minus 3y. Okay, then after that, it will make that this numerator here multiplies with a 2. This numerator here doesn't need a multiplication. Okay, it's actually multiplying with 1 now. Right, then after that, simplifying it, we get 10x plus 7y over 2 times 4x minus 3y. So that's fine. Okay, then looking at what Enqi has given us. Okay, so what she did is that she swapped it, right? Hence causing the negative become a positive. Then after that, also concurrently, she factorized out 2. So several steps being done concurrently here. Then after that, the remaining steps remain the same. Likewise for Xavier, okay, factorizing out negative 2, negative becomes a positive here. Okay, and then for which we see as corrected it because we forgotten the 2 over here and then get this. Right, so all the steps here. Okay, so